I'd like to welcome Ram Yurabundi, and who's the research manager for Watershed Hydrology and Ecology Research Division within the Water Science and Technology Unit of Environment and Climate Change Canada to the stage, along with Todd Nettesheim, environmental engineer with the US EPA. Ram and Todd will talk about the current approaches to binational coordination of Great Lakes science, which I think most of you know is its own annex under the Great Lakes Water Quality Agreement. So Todd and Ram, thank you for joining us.
Thank you, Cam. First of all, what I would like to say is, like the previous speaker, I too speak 3 languages, but they are completely different languages. And if I mix up those 3 languages, I'm pretty sure none of you will understand. So bear with me on that one. The other thing that I want to say is we are running a bit of late, I guess, today. And so if Todd agrees, our job is to bring back the schedule on time. So I will quickly wrap it up. I'm pretty sure many of you are also looking forward to wrapping up of all these annexes, and which we are going to do. And my name is Ram Yurabundi, and of course, my colleague here is Todd Nettesheim. I have a script, but I'm known to deviate from the script, so either it can be longer or shorter, depending upon how you are going to receive it. One of the things that we want to do here is provide an update. And I know it's pretty late in the afternoon, so I will be wrapping up quickly, as I said, with the most important annex, we believe, Science Annex, I guess. And the other point that I wanted to mention is Todd has actually recently taken over from Paul Houghton, who many of you know, and he has been a great support. And of course, we also have an excellent team in our team, annex team, Nancy and others who have actually are helping us with this particular annex. Okay, in the next 20 or 30 minutes, what you're going to hear is a brief overview from us on this agreement and what this Science Annex is about. Of course, I don't need to convince you after all these science presentations that science is still important, I guess, for the water quality agreement. And that's a given thing, and I don't need to really convince you on that. But of course, science also provides the foundation for the management actions and policy decisions for these agreements to meet their objectives. One thing I want to point out, though, is it's not only us, the government and non-government agencies that are doing science. There are many other people who are doing science. And one of the challenges for us is maintaining awareness of it. And it's a tremendous amount of work, and Nancy has shown how much work it goes through to assembling it and integrating and presenting it. And that's what one of our priorities are, the action items within our annex. Through our annex, of course, the thing that we are trying to promote is the collaborative science and how this particular type of science provides some strong foundation for the water quality agreement. Of course, we will also try to provide some progress, what we have been doing in the last 3 years, I guess, and then also talk a little bit about our future directions. This slide, in one fashion or the other, you have already seen, and you already know more than me about how the agreement came into the picture. But the only point that I want to make here is, of course, the science is the cornerstone here over the years, right from 1972 agreement that Sue Humphrey and Tinka Hyde has pointed out that started with the phosphorus load reductions to the lakes, which are obviously established at that time through the science, particularly the research, monitoring, and modeling that has been taking place at that time. And then there was the subsequent amendment in '78, and the lakes have been, and the lakes was, science in the lakes was extended to the toxic substances endpoints and incorporated these ecosystem management concepts into the agreement. And this was also pointed out by groundwater folks yesterday. And in the most recent agreement, the parties again recognized the need for comprehensively managing and addressing the current and emerging threats. That's something new. And most importantly, they also established this particular annex, Science Annex, and which obviously has to coordinate, which I will be talking a little bit later, but also try to assess about some of the emerging threats. For example, microplastics has been raised by many people, and an excellent presentation given on the climate change impacts, which is also very much into the picture as an emerging threat. So what are our commitments? I have gone back and forth with this one several times to understand the purpose of this annex after all those annexes which are also dealing a lot of science aspects. So our annex is essentially made to coordinate these science activities across these annexes. The point that we want to make here is our annex's purpose is to enhance the coordination and finding efficiencies in delivering most of these activities. So when we talk about science, for us, what we mean by it is monitoring, surveillance, observations, research, modeling, whatnot. And of course, the most and one of the critical aspects of it is also traditional ecological knowledge, incorporating that into the water quality agreement on delivering this. When we say that there is a science annex, like I said, it doesn't really mean that we are the ones who are doing all the science. We are only coordinating these things, and obviously each annex is doing their own science and their own priorities. And of course, there are lots of cross-cutting issues. If you take about dry cyanid mussels, both zebra and quagga mussels, and how they altered the nutrient cycling in the Great Lakes, this has implications for several things, right from the fisheries to food web, nearshore habitats, and nuisance algae. If you are counting, these are already 4 annexes we talked about, and we are trying to coordinate within those things and trying to find efficiencies in monitoring these activities. This particular slide is essentially to show that how a diverse team of experts got together under this annex. There are members from federal agencies, provincial, states, and First Nations, Métis, and tribes who are grouped into 4 particular themes, with our main focus being on the coordination of research and monitoring in the agreement. That is done through the CSMI, which Todd will be talking a bit later. And also we have subcommittees or the task teams that we are trying to do the indicators, which we started this whole conference with that one. And there are the 2 important task teams. The other one is we know that there is a lot of data available from many places, and everybody wants to have a look at it. So one of the task teams that was looking at it is to find the most efficient way of transmitting this data to the public. And the last but the least is the incorporation of TEK into the agreement and the water quality work. This is where we are still trying to improve the way how we are going to engage and how we are engaging the First Nations, tribes, and Métis in bringing their knowledge into the water quality agreement and delivering. Okay, this is just the slide. After that, Todd is going to take over, I guess. There's lots of work done in the last 3 years. Obviously, I can't cover all, and also I don't want to cover all and make you to sit here the whole day. The one thing that we do want to highlight is we are trying to reinvigorate some of the programs. In particular, we have been doing this so-called Cooperative Science and Monitoring Initiative, essentially for the binational lake-specific science commitments. And of course, the integration and synthesis is another part of our, and of course, assessment. This has been well presented by Nancy and Jackie yesterday. And as I said, we have started piloting a data management platform, which Todd is going to talk again.
Great. Thank you, Ram. And thank you, everyone, for being here today and offering me the opportunity to speak to everyone here about the work that we've accomplished under Annex 10 in the last 3 years. One of the core pieces of work done under the Science Annex is the implementation of the Cooperative Science and Monitoring Initiative, or CSMI. Ram mentioned that before. This is something that's been going on for quite some time. back, I think it was 2002, the parties and a larger group of people wanted a better way to coordinate our monitoring. Simple efforts of just trying to share sample bottles or share samples across lakes. So a group got together to just figure out the basic framework, how we can cooperate better on monitoring. The idea was we could just focus on a few issues in any given lake and dedicate extra resources to address that issue. The next year, a different lake would be tackled along with whatever issue they identify. So the first lake was Lake Ontario back in 2003. And the focus then was on the lower food web. For the Lake Ontario folks in the room, that was the Lola project, I believe. From there, we went on to Lake Erie in 2004, and then Lakes Michigan, Superior, and Huron, which is the same cycle we have now. Based on that successful coordinated monitoring, we included research into the framework in 2006. So instead of CRMI, it became CSMI, so science, which would broadly incorporate research, modeling, and other science activities that Ram mentioned before. And then in 2009, the upstream connecting channels were added to their respective lakes. So CSMI follows a 5-year cycle where we focus coordinated field work on one lake each year. So there are 5 lakes, so hence a 5-year cycle. If there were 6 lakes, I'm not sure what we would do. However, just because coordinated field work is happening for one lake doesn't mean that nothing is going on in the other lakes. The cycle also includes lab and analytical work. It includes reporting. It includes priority setting by the LAMPs and then planning for how the CSMI team can address those LAMP priorities in delivering a field year. So that's kind of depicted on the screen there by those little arrows on the bottom. So what this means is that in any given year, there's some CSMI-related work happening in each of the lakes. The final important point to note is that the CSMI team does not set priorities. I think this was clearly articulated during the Lake-wide Management Annex discussion from yesterday, that those priorities are set by the Lake-wide Action and Management Plan processes, and then it's up to the groups within Annex 10 in the broader community of how we can address those science priorities. So what are these science priorities that are spoken of? There's a lot of common priorities across the lakes because the lakes are facing a lot of the common issues. And these include those first 3 identified up on the screen. The lower food web, in particular, looking at benthic communities, including dry-scented mussels and dipraia. We've heard about that repeatedly since the beginning of the conference yesterday morning. Another one is looking at these nearshore to offshore flows of both energy and nutrients and their impact on primary productivity in the lower food web. Another common theme across the lakes is how ecosystem conditions and biological community compositions change with the seasons and how these changes may impact fisheries, in particular how they may impact fish or larval fish at important life stages, and how that also impacts water quality. But each lake also has unique priorities as well. For example, in Lake Superior this year, they wanted help in determining if progress was being made in the rehabilitation of lake sturgeon. They were also interested in establishing some baseline water quality conditions in critical streams entering Lake Superior. Lake Huron is very interested in the role of round goby and Cladophora in the fate and cycling of nutrients within the lake. Lakes Erie and Ontario, a lot of their priorities revolve around setting of objectives and targets related to Annex 4 under the agreement. And then for Lake Michigan, we're also interested in revisiting the Lake Michigan Mass Balance Project, which was a large study back in the mid-90s looking at contaminant loads and cycling within Lake Michigan. So the real second core area of work that's done under the Science Annex is the assessment of ecosystem indicators and reporting on the state of the Great Lakes. Yesterday, we heard a fantastic presentation from Nancy Stadler-Salt and Jackie Adams. So I know Ram wanted to go very quickly here, but it was such a great presentation, so I wanted to see if everyone wanted to revisit that entire 70-minute slot right now. Hopefully the organizers are okay with that. All right, maybe we'll go on and I'll give a few brief slides. So their presentation was based on years of effort working collaboratively with hundreds of Great Lakes scientists to assess a number of sub-indicators and aggregate them up into 9 indicators that are aligned with the general objectives of the agreement. The graphic here on the screen illustrates the type of data that's generated for each of those sub-indicators. Both of these graphics were shared during the presentation on Tuesday morning. The graphic on the left depicts PCB trends in lake trout in Lake Ontario. As you can see, concentrations have decreased dramatically. We heard about this in the Annex 3 presentation and in the State of the Lakes presentation yesterday. The graphic on the right depicts the changes in densities of dreissendid mussels in Lake Huron since 2000. The main message here is that it's critical that we continue to invest in long-term monitoring programs to track changes over time, in particular, how the ecosystem is responding to management actions and other stressors in the ecosystem. So continuing on the discussion of ecosystem indicators, I will quite dangerously try to sum up their 70-minute presentation with this one slide. And this is a slide that aggregates all the sub-indicators and indicators into one graphic that depicts the status and trend of each lake overall. This was also presented yesterday. And a key point to remember is that this is based on the input of over 100 authors and contributors representing over 30 agencies and organizations contributing to the overall assessment. So just revisiting what these status and trends are, Lake Superior is assessed as good and unchanging. Lake Michigan's, Huron, and Ontario are assessed as fair and unchanging, and Lake Erie is assessed as poor and deteriorating. The final State of the Great Lakes highlights and technical reports will be released in 2017. These reports will have a lot more information on the details of the sub-indicators, overall status and trends that we just heard a snapshot of yesterday morning. So the third major activity that's occurred under the Science Annex is making data and information available to the public. The work being done under the Science Annex will provide guidance on data management and sharing to assist the parties in meeting commitments under the agreement. This work should improve knowledge, accessibility, and exchange of relevant Great Lakes information. The work will guide agreement project teams in evaluating existing data sharing platforms and identifying those which will benefit their work. The group is working on an evaluation tool for this purpose. There are dozens of data sharing platforms in the Great Lakes region, and that's probably actually a gross underestimate. We've depicted just 2 of them here arbitrarily today on the slides. The one in the bottom right-hand corner is the Science in the Great Lakes Mapper developed by USGS. It's a portal that graphically displays environmental monitoring along with descriptive information on their efforts. The top image is showing the Environment Canada Data Catalog, which is part of Open Data Canada. The data catalog provides a one-stop solution to describing, publishing, and discovering environmental and scientific data from Environment and Climate Change Canada. For example, water observation stations across Canada monitor water bodies for changes in water levels and for pollutants, such as toxic substances generated by a variety of different sources. This information would be accessible on this data catalog. So the Data Management and Sharing Group under Annex 10 is working on a pilot project with the Nutrients Annex to assess and find solutions for data management and sharing needs of Annex 4. The pilot will test the evaluation tool that's being developed to help users assess and select data management systems based on the relevance, applicability, and usability. Based on the feedback from this pilot, the tool will be modified as appropriate. The ultimate goal is that this tool could be made available for use across the annexes in helping support data management and sharing. So So when Ram and I were in our team working in crafting the presentation, we recognized there's a broad suite of scientific efforts that are really supporting management decisions across the agreement. So we wanted to highlight just 3 examples, but there are many, many more examples out there. And those 3 examples are the monitoring for setting of phosphorus targets in Lake Erie, the assessment of the state of Cladophora science, and the assessment of connecting channels. The 2 overarching themes of these examples are the binational coordination and the integrative nature across government, academia, and other partners. So the first example of collaborative science activities is the development of phosphorus objectives for the western and central basins of Lake Erie. We heard extensively about this process by Tinka and Sue earlier today. The science behind the setting of these targets include measuring phosphorus loads to Lake Erie, maintaining a database of information so that tracking of information over time is possible and can be used to support the development of management strategies, research to clarify the role of how phosphorus is cycling in the western basin of Lake Erie and how this may confound management efforts, and continued coordinated monitoring to track progress on achieving load reductions, as well as assessing how the lake ecosystem is responding to these reductions. Through the work of the Nutrients Annex, it quickly became evident that more information is needed on the nuisance algae Cladophora before targets could be set for the eastern basin of Lake Erie. Specifically, we need to know what are the conditions that promote Cladophora growth so that we can minimize these conditions as appropriate. So what is the role of nutrient loads, lights, temperature, substrate in the ability for Cladophora to grow and proliferate in certain areas of the basin? So in order to find out what information was available and identify what information was still needed, a workshop was put together in early 2016. This was a joint workshop led by 3 annexes of the agreement: the Lakewide Management Annex, the Nutrient Annex, and the Science Annex. The workshop was attended by most of the Cladophora experts and researchers from around the basin. It included modelers and a few token policy people as well. The state of Cladophora science, research gaps, and identifying the best models to use were all discussed. The parties are now using these recommendations developed from the workshop to initiate new scientific efforts to support the development of phosphorus loads for the eastern basin of Lake Erie, and this will eventually be used for the other lakes as well under Annex 4. So the final example that I want to highlight today before I pass it back over to Ram is the assessment of connecting channels. So to support the commitments contained in Annex 2 for the development and implementation of a nearshore framework, Annex 7 for the completion of a habitat assessment, and Annex 10 for the inclusion of connecting channels in the CSMI process, Science Partners developed a scoping study to assess the nearshore conditions in the St. Clair River, Detroit River system, and the St. Mary's River from 2014 to 2016. These pilot studies were built on other nearshore assessments of coastal conditions around the Great Lakes Basin that measured things like water quality, sediment quality, and benthic community conditions. So the graphic on the left depicts concentrations of conductivity, which is an indicator of water quality conditions, at approximately 50 locations in the St. Clair River, Detroit River system. The graphic on the right shows the St. Mary's River system and the range of phosphorus values seen at their approximately 60 sampling locations. So while these studies aren't complete yet, ultimately they will help inform the more thorough assessments of connecting channels that will support work under Annexes 2, 7, and 10.
Thanks, Todd. The next slide shows basically what are our priorities for the next 3 years. Essentially, what we are trying to do here is continue this 5-year rotation cycle for the CSMI activities. Of course, we recognize that we can improve on some of the CSMI activities, and we will try to bring those efforts in coordinating with non-agency scientists, for example. And the indicators is the next one, and one of the priority for us is to get the 2017 technical report out and highlights report also. In the data management and sharing, of course, we are evaluating and piloting this particular aspect with Nutrient Annex. And if the tool is successful, we want to expand it to the other Great Lakes. That's the main priorities for action. And the Science Annex also asks for the coordination between different agencies as well as individual annexes. And essentially, this is done to fill the critical knowledge gaps. This is where we are really thankful for the IJC recently that they sent their comments to us, and we have been looking at those things. And in the next few months, we will those comments and the other comments that are going to come now will help us to finalize our priorities for science and action. Some of the other work that which is very, very critical for us is to explore the possibilities of incorporating the traditional ecological knowledge that can contribute to the water quality agreement. And this is a priority for both of us, and we will be addressing that soon. Just to wrap up this presentation, the point here is to tell that whatever we are doing is collaborative science. And collaborative science is the key word in the Great Lakes Water Quality Agreement. And most of these activities, we cannot do it by ourselves. That has been articulated by many people since morning. And we should thank many of them who contributed to this, and their logos are displayed here, but are also looking for many more people to help us in these activities. Thanks.